Hey guys, in this lesson, we're going to look at rational exponents. And remember, rational just means they're in fraction form. So we have to be able to convert between exponents and radicals. And so the thing to remember is what to do with that fraction. Okay, your numerator is your power. And so it is always going to stay with your base. So if our base is A, and m is the numerator, then a to the m, if you can see that over here, a to the m and a to the m. And then the denominator, our n right here, is actually going to become the index. So that goes outside of the radical. Okay, let's practice. So when we have x to the 1/2, we're going to take this 2 and put it outside and make it our index, and then x to the first is going to stay on the inside. And so we know that the square root of x to the first is going to be written simplified like this. Remember, we don't have to write the 2 and we don't have to write the exponent of 1. Okay, when we're looking at number 2, be careful with these because this exponent of 1/3 only applies to the a. It does not apply to the 12. This is saying 12 times a to the 1/3. So the 12 is going to stay exactly as it is, and then a to the 1/3 is going to be rewritten as the third root or the cubed root of a. Okay. For number 3, notice that the -6 is inside parentheses along with the x, and that is the only thing that is to the left of the 2/3. So we know that the -6x is actually the whole thing. The -6 is also being applied to that exponent of 2/3. Okay, and so we would keep our -6x. We know that it's going to be to the second power, and it's going to be in the cubed root. For number 4, we have a combination of 2 and 3. So notice the 3 is outside the parentheses that come just prior to the exponent. So the 3 is going to stay the same. Everything inside the parentheses is going to get this square root. So 25m to the third. And now we have to simplify. So we know that the square root of 25 is 5. And we know that of m to the third, we can pull one pair out. Remember that index of 2 says we're going to pull a pair. So the square root of m squared is m. And then we have 1m left over on the inside. Okay, and then we'll move this up so that we can have just a little bit more space. So now we can simplify and say 3 times 5 times m is 15m times the square root of m. Okay. Now, when we're writing in exponential form, we're going the other direction. So remember that whatever your exponent is here, in this case, it's a 1, is the numerator, and the number out here is the denominator. So 16 is my base, 1 is my numerator, 3 is my denominator. Okay, let's do the next one. 11 is my base, and it's going to be 2 over 3. This number on the outside always goes to the denominator. Notice that we have this fourth root and we've got -2a inside. So we're going to have to use parentheses to make sure that our fractional exponent applies to the -2 and the a. 5 is my power and 4 is my index. Okay. Now when we look at 8, notice everything is inside parentheses. So we're going to say 10 to the 5th, a to the 3rd, b, and this is all to the 1/2 because everything is inside the square root. Okay, in this section, we're going to simplify. We're going to write in simplified radical form and make sure that we have rationalized all of our denominators. So if I look here, I have 100 to the 1/2 power, which is the square root of 100, which is going to be 10. Now, I do want to point out, if this exponent were negative 1/2, remember that negatives mean you put them in the denominator of the fraction. So this is 1/100 to the 1/2, which would be the same as 1 over the square root of 100, which would be 1/10. So make sure that you're paying attention to your exponents as well for positives and negatives. In the next one, we have the cubed root of x times the square root of x. And so we are going to write those in exponential form. So x to the 1/3 times x to the 1/2. Now, the reason I did this is because a cubed root and a square root, I can't multiply them. They're not like terms. So if I convert them to exponential form, now I have the same base. And we can remember that when we are multiplying our bases, we have to add the exponents. Okay, so adding the fraction says we have to do 1/3 plus 1/2. So we're going to use the common denominator of 6. So this is going to give us 2/6 is 1/3 plus 3/6 is 1/2. So that tells us this is the equivalent of 5/6. So x to the 5/6 power, remember, is the 6th root of x to the 5th. Here we have a power to a power, so we're going to multiply those fractions. So 1 times 5 is 5, 3 times 2 is 6. And this again is going to give us the 6th root of a to the 5th. It doesn't matter if your exponent is inside the radical or outside the radical, because when you convert them, it converts the same. Just like at the top in your notes, I made that note for you. Here in this one, we're going to combine them because they're both the square root of 7. And so we can say the square root of 7 cubed over the square root of 7. We can combine those into a single radical. And remember, when we are dividing, that we have to subtract our exponents. Sorry, over here we multiply. So this is the square root of 7 squared, which we know is just going to be 7. Mark all the final answers to make them easy to find. Okay, you also could have done 7 to the 3/2 minus 7 to the 1/2, which would give you 7 to the 2/2, which is 7 to the 1st, or just plain old 7. For number 13, we're going to look at 25m squared, and we're going to raise both of those to the 1/4 power. I know 25 is the same as 5 squared. So I can say 5 squared times m squared to the 1/4 power, and now I can multiply my exponents. So 5 squared to the 1/4 is going to be 5 to the 1/2. And then m squared to the 1/4 is going to be m to the 1/2. So this is going to give me the square root of 5m. Both of them are to the half, so they both can go inside my radical.